Assalamualaikum and good day everyone. We are from Group 7. Today we will explain about the experiment 5, which is measurement of jet forces. This group contains me, Nora Lazim, Nozana, Nasrin Aina and Nur Amira. Okay, next. This is the content available in this presentation. Okay, move to the next slide. Okay, the abstract for this experiment is object like boat or rocket are moving use the jet forces method. Jet forces is exhaust from some machine like in the aircraft, propelling the object itself in the opposite direction due to the change of HTE momentum. Some others objects that are using the opposite direction due to the change the momentum. Some other objects that are using the same method are drones and satellites. Okay, next. We move to the theory in this experiment. The first one is a force will produce when a jet of liquid strike flat plate or hemispherical surface. So, due to the change in the momentum of the liquid, according to the Newton's second law of motion. Then, when the relationship in this experiment is when the velocity of water jet from the jet nozzle with diameter strike of flat plate or spherical surface, the rate of change of momentum produced and its magnitude is equal to the force applied to the plate. Hemisphere or hemisphere space support the water jet. Then the shape of the surface affect the force produced by the water jet. And lastly, the jet is deflected by a flat surface, cleavage through an angle and leave the surface with the velocity. So these three equations we will use in this experiment to get a force. Okay, next we move to the next presenter.
Okay, so the objective of the experiment is to compare the force exerted by a fluid jet impinging upon a flat plate or a hemispherical surface with the theoretical value. Next. So these are the apparatus used in this experiment, which are wake position, deflector, nozzle, level mechanism, tank, water supply, water drain, main switch bulb, flow control valve, volumetric measuring tank, and lastly, sliding valve. Next. So these are the procedures of this experiment. Okay, the first one, the tested deflator is assembled. The pointer is set to 0 by adjusting the screw at the lever mechanism. While doing so, the weight is not placed on the lever mechanism. Next, the main switch and the pump are turned on. Next slide. Okay, so the flow control valve is slowly opened and the desired weight is put on the lever mechanism. The flow control valve is adjusted until the pointer at the lever mechanism is at the 0 notch. The sliding valve is closed. The flow rate of water Q is determined based on the time recorded T that is required to fill up 3 liters of water in a volumetric measuring tank. Next is the sliding valve is open, and then steps 4 and 5 are repeated by increasing the desired weight on the lever mechanism until the flow control valve is at maximum opening. Next. Okay, the main switch and the pump are turned off after that, and the sliding valve is open and the flow control valve is closed. Lastly, the weight is removed on the lever mechanism and the deflector is changed from plate to hemispherical surface. And steps 2 to 7 are repeated. Okay, then I'll pass to Zana.
Okay, so for raw data and analysis, we need to record the data that we get from the experiment by using table 1 and table 2. So the data given, density of water, which is 100,000, which is 1,000 kilogram per meter cube, diameter of nozzle. This is the table that we need to, this value we got from experiment, which is measure force, volume of water, and also the time. So we need to calculate Q actual, V theoretical force, and also percentage of relative error. So want to calculate this value, so we need to do this step, which is the formula for Q actual is a volume of water collected divided by time. Then this is the example, and we need the area. So pi d squared over 4, and we also need to calculate V. So we know the value of Q equal to VA. So we can get the V from that formula. So we will use to find force, we need this formula. This formula is for flat plate, and also this formula is for hemispherical surface. All the data in table 1 and table 2 must do a calculation by repeating all of these steps. So from the step we look there, we can get all these values. So the average theoretical force for flat plate is 2.3736 Newton, and this is a table 2, which is data for hemispherical surface. So this value we get from that step as I explained. So the average theoretical force for hemispherical surface is 4.4564 Newton. So, okay, next I will pass to Amira for the discussion.
Okay, for the discussion, first question is to plot a graph of log F MVA versus log V for both the flat plate and hemispherical surface on the same graph based on the table 3 and table 4. Next. Okay, so this is the graph that we get by using the value of table 3 and table 4. Next. So for the question regarding the graph, estimate the slope of the graph for both the flat plate and hemispherical surface and compare with the theoretical value as shown in equation 2 and equation 4 respectively. So from equation 2 and equation 4, the formula for F is the same, but the formula for the log FTH is not the same as shown here. So from the experimental result and graph plotted for flat plate, y equals to 1.7006x minus 0.9047, which the slope is 1.7006. And for hemispherical surface, y equals to 1.8414x minus 0.686, where the slope is 1.8414. The slope for flat plate from experimental and graph result is 1.7006 compared to the theoretical value, which is 2. So there is slightly difference between both value, hence the value is considered accepted. And also the same for hemisphere surface, which has slightly difference with the theoretical value, which experimental and graph result we got is 1.8414, while the theoretical value is 2. So the value is still accepted. Next. Okay, so for the second question, which is estimate the y-intercept ratio of hemispherical surface to flat plate and compare with the theoretical ratio. So for flat plate and hemispherical plate, the formula for F is different, which is for flat plate, F equals to rho AV square, while hemispherical plate F equals to 2 rho AV square. So from both equations, we can see that both are similar to y equal to mx plus c. So we can get the value for y-intercept from the equation of graph. So we use the same one as before, which is y equal to 1.7006x minus 0.9047, and then we got y-intercept 0.9047. And the next one is y equal to 1.8414x minus 0.686, and we got negative 0.686. So for the y-intercept ratio, we need to divide negative 0.686 with negative 0.9047. And for the theoretical ratio, we must divide the Newton value, which is 4.4564 over 2.3736. So the value of theoretical ratio and experimental ratio is different due to the losses that happen in the system flow, such as major losses and minor losses. Hence, the value for theoretical and experimental different. Next, compare the force exerted on the hemispherical surface with the one on the flat plate, which one is greater and why. So the momentum impact caused the exerted force on hemispherical surface greater than the flat plate. The exerted force depends on the shape of the plate surface. So for flat plate, the velocity go 90 degrees to the left and right after impact to the flat plate. But for the hemispherical surface, the velocity go total angle of 180 degrees to the left and right after impact the surface. From the equation 2 and equation 4 itself shows that the force impact on hemispherical surface is 2 times greater than force impact on flat plate. Okay, for the next question for discussion is compare the percentage of relative error for both the flat plate and hemispherical surface as function of jet velocity. So based on the experiment result, the average of the percentage of relative error for hemispherical surface is higher than flat plate. Supposedly, it should be otherwise because the shaped surface of the plate influences the percentage of error. Due to the uneven shape of the hemispherical surface, the redirected force of the jet is not uniform and reflects back to main jet water stream, causing various force output. Compared to the flat plate with even surface for jet impact to be directed, it will be more uniform and away from center point and produce more consistent results. Other than the shaped surface, other errors also contribute such as external weight applied and the balance which cause imbalance. So the common question for discussion is briefly discuss on factors contributing to errors or inaccuracy in experimental data and the possible recommendation to improve the existing results. So for the factors in this experiment is reading errors due to friction force, time lag caused by the long distance between the water jet and reservoir tank, and as usual, parallax error. So the recommendation to overcome these factors is first, calibrate the equipment before the experiment, use smoother pipe and reduce the length of the pipe and uses of pipe joints. Use single water pump instead of double water pump that connected in series to reduce water friction. So basically, recommendation 1 and 3 is to reduce the friction force. So next, number 4 is to reduce the distance to eliminate time lag error. Make sure eyes are perpendicular to the scale and carry out experiment repeatedly to get more accurate results. Okay, so lastly for the conclusion, the purpose of this experiment is to compare the force exerted by a fluid jet impinging upon a flat plate or a hemispherical surface with their theoretical value. So in this experiment, we can conclude that the force exerted on the hemispherical plate is greater than on the flat plate. There is also difference between the actual and theoretical values due to some errors. And the average of the percentage of relative error of hemispherical surface is higher than flat plate. So that's all from us. Thank you.